So now, in my last video, I used this schematic here in basically this circuit, except for I accidentally had a 10K resistor in this spot. I purposely put it there because I wasn't paying attention to this schematic that I drew a long time ago. And it's pretty obvious why I wanted the 3K. So I'm going to dim the lamp right now. When I get to the lowest setting, now the blue LED lights up. So we have a low output now, whereas we had a high output. I'm going to make the lamp a little brighter. High output when the red LED is lit up. And that's due to the difference in resistance of the 3K versus the 10K. Because in the last video, I'm going to yank this 3K resistor right there and take the 10K and put it to the negative supply right there. So yeah, now I can cover it, you know, to make it dark enough. But this is the lamp's lowest setting right there. We were just a little bit above that. I have to actually turn it off. So I did mention in the last video that one way we could adjust the sensitivity was by changing one of the values of these resistors, or you could change them both, you know, but it's easiest to go up or down in voltage if you just change one. And so yeah, we got that 3K back there. But you could also change this resistor. The light dependent resistor, I have a pack of them, different part numbers that have, you know, a bit different resistance at different light levels. So you may be able to grab a different light dependent resistor that might get you to where you have the light level that you want between these 2 points. But more often, you're just going to accept it's going to be whatever resistance the light's falling on it. That's not as much in your control, other than you can control how much light is falling on it. This fixed resistor, it's really easy to swap out with a different value. So if I wanted, we saw if I had a higher value resistor, it would still be high until I got it really dark. Which means if we wanted to make it so, like right now, we had a low output, 2.2K would definitely make it low right now, but I'm not sure. Maybe the reason why I didn't use 2.2K is because at the brightest setting it wouldn't turn off, or else maybe I had to be really close to the brightest setting, and instead I wanted to be down to the lowest setting before it gets low. So again, I made this diagram a long time ago. I don't know why I went with 3K, but it's pretty obvious here that 3K is only the lowest setting of the lamp, or darker, where it turns off. So, in any case, I'm not going to go over the circuit in great detail. We did that before. It's a non-inverting comparator. So we set the reference voltage here, which is half of the supply voltage, and I'm bumping the power supply. That's why the light's turning off. And by the way, I do have 5 volts right there. That's another thing I get wrong sometimes. I think it's set to 5 volts, but I have a different voltage. But I do limit current there to like 20 milliamps. So usually I don't destroy anything, but I try to always set it to 5 volts. But again, this is a non-inverting comparator, which means we have our reference voltage to the inverting input, which is actually above the non-inverting on the integrated circuit. So it's at pin number 2 there. We got our fixed resistors to the positive supply and negative supply, and we're tapped into the middle of that. Our signal voltage, that's our reference voltage. Signal voltage is coming to the non-inverting right there. The output always wants to be more like the non-inverting input than the inverting input. So again, we got like the 2.5 volts there. If we got enough light that this is above 2.5 volts, so that would mean this would have less than 3,000 ohms of resistance in this case because of that resistor, then we'd have a higher than 2.5 volts. We'd have a high output there. It doesn't quite make 5 volts, but you know, relatively close. You lose about a volt from the supply voltage. If we get it dark enough, then we'll have more than 3,000 ohms of resistance up there. So it'll drop the voltage below 2.5 volts. So it'll be lower than that one. We'll have a low output to ground, which it does connect to pretty good. So just a brief review. And they don't always have the supply pins on there, but you always have to power it. Those 2 pins, positive and negative. So again, this was just meant to be a brief video, but hopefully you enjoyed. Again, I'm correcting the mistake I made in the last video when it came to what was on the schematic. So I had annoying writing on the screen, but you know, I'm not planning on getting tons of views for that video, so I think this is a better lesson that, you know, pay close attention to the schematics, but also you can modify the schematics to get the results that you want. That's actually what you should be doing. You shouldn't be, you know, I need to find the exact schematic that will solve my problem. You probably aren't going to be flashing LEDs or something. You might want to be using this to switch a relay or something. You're going to also have to add a transistor because this isn't strong enough to power relays directly, but you could power a relay module, the signal going to it. So always plan on, when you're learning circuits, the modifications that you can make to do something that you find more interesting than what they showed. All I'm really showing here is the basics of a non-inverting comparator when you're using an op amp. There's also comparator circuits, but their outputs are different, and so that's something you got to learn if you want to use one of those. It's always expanding on what's on the schematic, not that the schematic is going to solve all your problems on its own. It's just inspiration for how you can use that component to ultimately obtain what you want. So again, I rambled on long enough. Hope you enjoyed. Make sure you check out one of the other videos I post on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.